Okay, so this is a video about mental methods of calculation and how we can think about mental calculation as a useful thing to prepare us for an exam or a test. So here are students from Stanford University being given a problem, a calculation, very straightforward problem. They get the answer almost straight away, but then they're asked by the researcher to tell us exactly how it was that they got that answer. What steps did they go through? So what was the problem that they were dealing with? It was simply this. Let's just erase that. Okay, let's make this clear. So calculate mentally, and you might want to do this yourself, so just see how quickly you can do this or how effectively you can do it. Calculate mentally 5 times 18. Okay. So hopefully you got an answer there. 5 times 18 is 90. But how did you get to that answer? What steps did you go through? Okay, let's go through what some of the ideas the students give us. So the students said, for example, or at least one of them did, the first student said, well, what I did was I took my 18 here and I doubled it. So in other words, they did times 2. So if we double this, then we're going to get 36. And if we double it again, then we've got times 2 again, we've got 72. Now 72 is not quite there, so we need one more 18 to get us to the total of 90. So that's the answer. And you might be familiar with this sort of thing or recognize this sort of thing because it's what we said in an earlier video. It's the sort of method you would use if you're working on a division. In other words, it's a partial quotients method. But in this case, rather than having 90 as the dividend that we were trying to divide up, this time they know they've got to multiply by 5, so they already know it's 5, and that's when they've done it 5 times, they're getting the answer 90. So it's a kind of inverse of the partial quotients method. Okay, now slightly different thing and more common method is to change the rules of the game, which is something I think is often a very good idea. So several students said, well, 5 I can't really do anything with, but the 18 I know I can split into 2 parts and that it will make life easier if I do that. So decomposing the number is a really good strategy, and one of the students at least said, well, I can cut it in half, so I've got 9 here, so 5 times 9 is 45, and I've got 9 here, so 5 times 9, 45. I've doubled, in other words, times 2 to get to the answer, total of 90. Okay? And that leads us to thinking about, let's put it over here, a third method which several of the students used, which is maybe more familiar to us. And that's when we slice that 18 into 10s and 1s. So we've got 10 plus 8, in other words. And so we've got 5 times 10 is 50, and 5 times 8 is 40. 50 add 40 gives us our 90 again. So that's if we recognize that the 18 can be decomposed. Other students realized that the 5 could also be changed. So we have this kind of thing going on. We've got our 18 at the top again. Let's keep that the same. But this time, well, one of the students said, let's see if we can just, get that to play. So one of the students said that what they were doing, okay, it wants to freeze, never mind. One of the students said that what they were doing was they were thinking of 5 as simply 10 over 2. 10 divided by 2, in other words. And so they multiplied out, they could multiply that out mentally as 10 divided by 2, that improper top-heavy fraction, giving them 180 divided by 2, giving them 90. I suppose a more sort of basic way of thinking about that, and a more sort of intuitive way, is that if we have 5 here, so we have 5, what we can do is double it, so have another 5 times 18. That means we've got 10 times 18 equals 180, and then, well, then half of that, so halve it after doubling it, takes us back to get our answer of 90. Finally, one of the students at least said, well, 18, that's nearly 20. So what I do is think of this as 20 to start with. So let's make it slightly longer here. So we've got 20 here. And then what they did was, having thought of it as 20, realized they needed to subtract 2 to get back to 18. So it's 18, in other words, is 20 subtract 2. So 5 times 20 was 100, nice friendly number then, and then 2 times 5 is 10, so subtract 10 gives us our 90. Okay, let's get this video going again. There we go. Okay. Oops, there we go. Right, so what we've got here is 5 different methods of getting to the right result, and that in itself is interesting. Shows you what a creative subject maths is, and how being flexible, being able to change numbers in different sort of ways, being able to decompose numbers like we did here, or being able to split them up, halve them, change them into tens and ones, or thinking about chunking. All of these are really important things for us to practice. So what I think we can learn from this to start with is it's not a case of saying, well, I wouldn't have done it that way, I would only do that way. That kind of rigid way of thinking isn't going to give us the practice we need. It's better if we think, well, what if I take another problem? So let's try another multiplication problem and try all these different methods, try different ways. How many ways can I think of getting that result? Another thing we can learn from all this, I think, is that if we're preparing for an exam, being mentally fluent, being fluent in number is of course extremely important. But when we're in an exam, the last thing we want to be doing, let's just change the ink color here. The last thing we want to be doing when we're in a test is trying to do complicated things mentally. What we could think about, though, is using some of these visual methods of, the methods we've used here to visualize what the students were doing, actually in a test, in an exam, to help us think more carefully about what we're up to. And I'll show you what I mean. If, for example, we had 5, well, yeah, let's just use 5 times 18, the same number. If we had that in an exam, we might be tempted to just jump to the result. But maybe what we should do is just very quickly in the margin, draw a little diagram, write down what it is we're doing, and think a bit more carefully about how we're going to tackle it. Are we going to add 2 to this and then subtract 2 to get the result? Are we going to, if we've got a 5 here, are we going to multiply by 2, or think of it as 10 divided by 2? We might even think about it in terms of a visual object, an area here. How are we going to split this up into 2, giving us 9 plus 9? So just a few moments to diagram the problem, rather than just leaving it in this format, might help us think about better ways, or more reliable ways, of getting to the answer that we want. Okay.